I'm Stan Williams of Hewlett-Packard Labs in Palo Alto, California. Along with my colleague, Greg Snyder, we authored the paper Nano CMOS Architectures using a field-programmable Nanowire Interconnect that was published by IOP Nanotechnology in 2007. This paper was the result of a convergence of several research streams that we were following. We had been looking into how to build a computing machine with nanoscale devices. We were concerned that any such computer would inevitably contain a significant number of defective components. Thus, the question was how to build a reliable machine out of unreliable parts. Greg had been the chief architect of a computer built at HP called Teramac. This was a defect-tolerant supercomputer constructed with field-programmable gate arrays, or FPGAs. Teramac intentionally contained a large number of non-working components, but it was able to test itself reliably and route around the defects. Our goal was to extend this architecture to the nanoscale to build a configurable logic system. The configuration bits and routing circuits would be based on resistance switches, devices that we later showed were memristors. In addition, we were inspired by a very clever routing scheme that had just been invented by Professor Kostya Likarev and then graduate student Dmitry Strukov at SUNY Stony Brook. They called their architecture CMOS, a hybrid of CMOS and molecular electronics. Our nanotechnology paper was a design study for an FPGA-like circuit that combined scaled CMOS, nanowires, and memristors. We showed that it was feasible to obtain order of magnitude decreases in chip area and operating power compared to chips made with only conventional CMOS. This result encouraged us to build a prototype chip using nanoimprint lithography to fabricate a nanoscale memristor crossbar on top of conventional CMOS circuit. We demonstrated that the idea worked by configuring logic operations from the components in the CMOS by connecting them through the memristors. The combination of our nanotechnology paper and the subsequent experimental demonstration has spawned several international workshops and conferences. I am aware of at least 2 companies that have announced plans to introduce FPGA-like products based on this concept. Although we are still interested in FPGAs, we have focused more on a couple of different applications. We are developing memristor crossbars for non-volatile memory and storage, which represents a much larger market than FPGAs. Our longer-term goal is to use a hybrid memristor and CMOS structure, similar to that described in our nanotechnology paper, to construct Cortex-like circuits that are capable of cognitive tasks, such as object recognition, navigation, and learning.